Hi everyone. For my long video, instead of using the PowerPoint slide, I'd like to do a walkthrough of my notebook, which I run using Google Colab. My final project is about stock market prediction using deep learning. So, for starters, what I like to do is let's click on the connect because and then under change runtime type, I had wanted to just quickly go over the configuration I use for my final project. So essentially, I didn't have to use any of the GPU compute power. I went with CPU, and with the high RAM option turned off, I clicked on the save, and for my final project, essentially, I'll just quickly scroll through. There is four deep learning models that I trained to try to predict prices of exchange traded fund, and the entire notebook took minutes to complete running. So no GPU power was required. Um, n- let's next deep dive into the code, starting with the abstract. So, um, to predict stock market prices, I've used four different deep learning techniques. The first one was to set a baseline, almost like let's reuse the LSTM model that um, we all learned in problem one and problem two of assignment 10. And I've gone with problem one to reuse the code of problem one for my first technique. The second technique I chose was similar to LSTN, gated recurring unit. They are both RNN, so recurrent neural network approach. So the on top of the first approach, LSTM, I use GRU approach as my second technique. Number three, I decided to try out CNN, convolutional neural network approach, to forecast the price of S&P 500 exchange traded fund. The last approach I decided to try is a hybrid approach, combining CNN, the third technique I chose, and LSTM, the first technique I chose. And it turns out all four deep learning approaches, and we'll go through the code in more detail, do a pretty good job in terms of prediction accuracy. And I have chosen two metrics in my final project to measure how good or how bad each of the model is relative to one another. So the first one is MAE, as we know, mean it stands for mean absolute error. And the second metric I use is MSE, and as we know too, it stands for mean squared error. And finally, yeah, I guess we started off by touching on the computational perspective to run this um, notebook, and GPU is not required. So moving to the next section of loading the time series data, the approach I use is to go to Yahoo Finance, because Yahoo Finance, as we know, is pretty good for equity prices, historical equity prices. And um, the way I downloaded data was to use the Yahoo Finance API. So I also decided to go with 5 years of historical data. So when I worked on this final project, it was around early December, December the 6th to be exact. So um, that's that's the last data point, December the 6th, 2024, and I go back 5 years to 2019, December the 6th. And out of the 5 years of data, I decided to use the most recent 3 months of data to be my test set, and to use over 4 years of data to be the training set. And moving on is the next section is the data exploration. So before using the data downloaded from Yahoo Finance, let's take a look at how good or how bad the historical prices are. And did some cursory checks, the count, and there's no, for each of the data attribute, adjusted close, high, low, open volume, there was no missing data for any one of the attributes, and they all add up nicely to 1,193 data points. So I took a look at the beginning of data plot and look at whether there's any big spikes or big drops to suggest it's a bad data point. By and large, it looks good. The data looks good. And I'd like to um, make a point which was mentioned by Diane in one of the labs, that, um, and I agree with her opinion, is the data set by and large has become cleaner and better over time. So the data set online. So I would say, in my humble opinion, Finance Yahoo historical prices are pretty good. So I didn't have to do any data cleansing adjustment to the S&P 500 ETF prices, and similar to problem one of assignment 10, I went with using just the open price to train the four models, starting with LSTM. And we can see the code is very similar to what we saw in assignment 10. So um, it's pretty much a reuse of my code from assignment 10. So here we kind of have a quick look at the model summary. And for all four approaches, I've used 100 epoch. Uh, and further down, if we scroll, then we'll see the actual. Let's take a look at the actual results, the prediction for the most recent 3 months leading up to December the 6th, 2024. And we can see there should be the MAE and MSE right here. Yes. So MAE is 5.4, and this is in units of US dollar. Um, and the mean square error will be like US dollar squared, but uh, the units doesn't make too much uh, sense, but we see that it's 45, and 45, just preview, out of all the four models, is the lowest. So LSTM turned out to be the best approach out of the four. So quickly, if we move on to the second technique, GRU, for gated recurrent unit, very similarly, we bring in the price, split it into training, the same split, and it's chronological. So there's no randomness about picking the um, what which day is the training set, which day is the test set. It's chronological. So then um, we essentially build out the GRU model, which is the summary of the second technique. And similarly, I use consistently 100 epoch to train all the models. So that's training was pretty fast, like in terms of millisecond for each of the epoch. We can see here, so it's really fast actually. And quickly to scroll to the prediction, and we can see the MAE is higher, slightly higher, 7.6 US dollars, and MSE is also higher than the LSTM model for GRU is 76 US dollars squared. But then quickly we move on to the third technique. Let's see how CNN approach perform. Uh, Again, uh, it's the same way to load in the data, exactly the same data split into training and test set. And here's the model summary. Um, then again, consistently 100 epoch for training the model. And we see for CNN, by and large, they all do a pretty good job. The red line being the predicted value, the trend is definitely accurate for so far of all the three models we looked at. Although, uh, let's take a look at the MAE. So CNN model is better than GRU, the second approach, but worse off than LSTM. So if we rank all the three so far, LSTM is number one, CNN is number two, as we see here, and GRU is number three. So then the question that I came up with is, hey, why don't we take a look at the hybrid approach of combining CNN, the third approach, and LSTM, the first approach? Let's see how the hybrid approach performs. So quickly again, same data split as before. Here's the model summary, and then consistently 100 epoch as well to train the hybrid model. And let's fast forward. Yes, so here is the prediction. And we see the MAE, the MSE is actually about the same range as the second approach, which is GRU. So if we kind of summarize, LSTM is the best, followed by the third approach, which was CNN, and then um, further down is, I would say, GRU and the hybrid approach are about the same. So in conclusion, I would say by and large, all four approach does a pretty good job. The trend is definitely correct. Um, I kind of paraphrasing Professor Zoran's comment um, in one of the lectures, um, and actually I will take the good advice of Professor Zoran, and I personally would not use deep learning technique to trade stocks in the real world because um, my personality is risk adverse, so I do want to be very careful. But I also do want to take the opportunity um, to repeat another point that it's a good point that Diane raised in the same lab. Believe it was um, the first week of December on the Saturday. So Diane mentioned is like everything moves so fast. The technology, the progress in deep learning is ever changing. So potentially there'll be exciting more. There'll be new approaches, exciting techniques we could apply as a next step to see how well the new models or other models, other approaches will perform in terms of forecasting the price for S&P 500 exchange traded fund, the data set I chose for my final project. So, for example, in my presentation slide, in the conclusion section, I mentioned potentially as a next step to try other deep learning models such as VAE, which as we know stands for variational autoencoders, as a different approach to try to predict um, the stock market prices. And I'm almost at the 15-minute mark. Thank you for hearing me out. And it's been a wonderful journey, like CS, CI, E-89 deep learning course. So truly learned a lot. and it was an amazing journey together. Thank you, everyone, and that's it.